All right, 1.6, solving absolute value equations. Now, we all know what an absolute value is. We know that if we have the absolute value of -5, that goes to 5. I think in the last video, I talked about how if we have 0 here and we have -6, we say, well, these are 6 units apart. And that's where that absolute value gets to. Absolute value talks about the distance from 0. That's a way to think about that. So some properties of absolute values. We know that anytime we have something in absolute value bars, it's going to be bigger than 0, bigger than or equal to 0. The negative version inside it is equal to the regular version. So this would be like -5 is equal to 5 in that sense with absolute values. With AB here, we could say like, I don't know, -5 times 4 is equal to the absolute value of -5, absolute value of 4. And then the fraction one, I think that we can all see how that would work. Let's get to solving. Anytime we have something where there's a variable, and this would be something like we got 5x plus 6 equals 3, like that. The variables inside the absolute value bars, whatever it equals has to be bigger or equal to 0, right? There's no way for this guy to go negative. Right? And there might be some problems like that where you'll see something where it's like, I don't know, absolute value of 6x equals -5, right? That could never happen. This is going to be no solution. Okay, if you see a homework problem like that, that's going to be no solution. Assuming it's not like that, assuming it's a nice number like 3, then what you're going to do is you're going to get rid of the absolute value bars and split it up. You're going to have one of them that all you do is take away the absolute value bars. And the other one, you take away the absolute value bars and you multiply the piece that's not in absolute value bars by -1. So let's look at this and let's see how this would work. Number 1 here, we have absolute value of x plus 6 equals 11. 11 is positive, so all works. It's not a scenario like this. Everything is okay. So this splits up to be x plus 6 is 11, and x plus 6 is -11. This gives me, what is this, x equals 5 and x equals -17. Right? And if you go back and you plug those back into the original problem, you'll get the correct answer. Number 2, the absolute value of 2x minus 1 is -4. Now here we should see alarm bells going off. This -4 messes us up. This is going to be no solution. There is no way to take the absolute value of something and then get a negative number out of it, all right? And again, there's going to be some homework problems, or at least I'm pretty sure there's some homework problems like this. You need to make sure that you look at this. Number 3, now this one's kind of different. Before we can deal with our absolute value bars, we're going to get rid of this 9. We get rid of it by adding it to the other side. So now we're going to have 3x minus 6, the absolute value of 3x minus 6 equals 6. Now we're going to solve it just like what we did in number 1. So this splits up to be 3x minus 6 is 6, and 3x minus 6 is -6. So here we have 3x is 12, so x is 4. And then 3x is 0, so x is 0. And there we are. Next up, solving equations with 2 absolute value bars. So what if you have absolute value on the left and the right side? The way that we're going to do this is similar to the way that we have already been doing them. We have one where all you do is you drop the absolute value bars. And the other one where you drop the left side and you multiply the right side by a negative, or by -1. So let's look here. Number 4. We have absolute value bars on both sides. So on the left side, 3, oops, I need to drop my absolute value bar. 3x minus 4 is x. And then we're also going to have 3x minus 4 is negative x, right? So here on the left, we could solve this, and we'd have, well, 2x is 4, so x is 2. On the right side, we could solve this, and we'd have 4x is 4, so x is 1. All right, number 5. Just like in number 4, we're going to still be splitting it up and making like a positive and a negative version of x, or of the right side rather. But we have this 2 sitting out front. So let's look here. We're going to have 3x minus 8 equals 2 parenthesis 4x plus 1. And then we're going to have 3x minus 8 equals negative 2 parenthesis 4x plus 1, right? We still have this positive and negative version, but there's a 2 attached to it this time. It makes it just look a little bit different. On the left side, I'm going to distribute my 2, so I'll have 3x minus 8 is 8x plus 2. This gives me, what will this be? I'll have a negative 10 on the left and 8,765x on the right. To get a negative 2 is my x. On the right side, whenever I distribute my negative 2, I'll have 3x minus 8 is negative 8x minus 2. I'll pull my x's to the left, so I'll have, what is that, 11x equals, is that 11? 8, 9, 10, 11, yes it is. And then 876, 6 on the right. So then I get x is 6 over 11. Well, that doesn't look right. Did I do that right? Looks like it. Huh. All right, I'm going to type this back in just to make sure that this works. 3 times 6 divided by 11 minus 8. That gave me negative 6.36. And then 4 times 6 divided by 11 plus 1 times 2. Yep, it works. Okay. Sorry, I was just questioning myself. Next up, an extraneous solution. And this is something that's going to stay around for a while. An extraneous solution is something, somehow the equation kind of breaks while you're making the, while you're getting your answer. It breaks in a way that it gives you an answer that isn't actually an answer. So that if you plug back in, you'll find that, well, that never happened. That was a bad answer. So the way that we do that is we do our problem like normal, and then we have to plug it in and check, right? Like how we have always known how we can check our work for solving regular equations. That's what we have to do here. But sometimes whenever we check our work, we'll get it wrong, and we're not really wrong. It's just that that answer is bad. So let's look at number 6 and do that. We're going to have 2x plus 12 equals 4x, and then we'll have 2x plus 12 is negative 4x. Solving the left side, I'm going to have 12 equals 2x, so 6 equals x. And then solving the right side, I'm going to have, what is this, 6x is negative 12, so x is negative 2. Now, we need to plug back in and see if we can get a good answer. And I think I can already see which one's going to be bad. But let's pull this over here and we'll plug in the 6. So we'll have 2 times 6, oops, 2 times 6, plain old 6, plus 12 is 4 times 6. Well, 2 times 6 is going to be 12, plus 12 equals 24. Well, that's good. Now, if we were to plug in the negative 2, we'd have absolute value of 2 times negative 2 plus 12 equals 4 times negative 2. Now, if we look here, it's going to give us a negative outside our absolute value bars. Well, we know that's something that just doesn't work. So this is a bad answer. It's not that we messed up anywhere, it's just that it's an extraneous solution. The way that I signify that is I just cross it out like I did there. Number 7, we'll have x plus 5 equals x plus 11, and then x plus 5 equals negative x plus 11. So on the left here, we'll get, well, our x's cancel, and we're left with 5 equals 11. So that's no solution. On the right side, we can get x plus 5 is negative x minus 11. So we get, well, 2x is, what is that, negative 16. So x is negative 8. Really, it's not no solution. It's just that way it doesn't have a solution. Let's plug in our negative 8 and see if it works out. We'll have negative 8 plus 5, negative 8 plus 11. Well, negative 8 plus 5 gives me, what is that? Negative 3. Negative 8 plus 11 is going to be 11, 10, 9, 8, 7, 6, 5, 4, 3. Is that right? 8, 9, 10, 11. Yeah, that gives me a positive 3. Well, that works out. So negative 8 is a good answer for us. All right. So sometimes you might have ones like this as well, where it ends up having a no solution in the middle of it. Okay. All right, that is absolute value. Make sure that we remember the idea. I don't have another one, do I? Nope. Make sure you remember the general idea that absolute value is a distance, right? It's a distance. You think of that as a distance, and that helps that helps me think about it. So hopefully it helps you as well. All right, that is 1.6.